Here are the answers to yesterday's homework. Order of operations, BEDMAS with integers. BEDMAS with fractions is coming later. Okay, there's the first 10. Comments, questions, concerns on any of those? Just going to slide my way up here. That's the bottom of the page. Questions, comments, concerns on any of that first page. Does anyone want me to do any of those 16 questions? Going once, twice, thrice, sold. Okay. How about this page? There's the from 17 to 26. Here's the bottom 4. Comments, questions, concerns. Would anyone like me to do any of those 17 to number 30? I know on the first day I really pumped up this whole, asking questions, taking ownership of your education, because who cares what other people in your class think? But I do also recognize that this is grade 9, and all you can do probably is think about what other people will think of you. So if you do have questions, and you just don't want to put up the hand, if you could make like an uncomfortable level of eye contact with me so that I know that there's something going on, and then, we could also just write the number of the question on the front of the board. If you've got questions, we got to find a way for you to communicate those out, because I want to help where help is needed. If you did not get the answers that I got for any of these first 30, I want to help you. Don't just copy down my answers. I want to make sure you understand why you got what you got. Okay? Uncomfortable level of eye contact. It's the way to do that, unless you're willing to ask these questions another way. Okay, here's up to question 36. Nice. I can upload some more here now. And there's the bottom 4. Nice. Cool. Okay, so there's no questions about any of the homework. Y'all did it all. Y'all got perfect. Or if you made mistakes, you understand why. The level of silence is really uncomfortable. But that's okay. I'll assume that we're good. Okay, then flip the page. Let's talk about fractions. We're going to review them, what they are and how to work with them. It's going to start and you guys are going to be like, this is really lame. I know what fractions are. That's cool. Humor me. We're going to start and we're going to fly through a review today on simplifying fractions and converting them between all their forms. So, fractions are useful tools because fractions represent a portion of a whole amount of stuff. You guys know this. So if I have a pizza, my first example here uses the pizza. If I have a whole pizza here, how many slices is that thing cut up into? Yeah, there are 6 slices to start. So how many equal slices are there in this whole pizza? Yeah, you bet. Still 6. Nothing's changed there. So if I have 6 slices to start with, and all 6 of them are there, I have 6 of 6 slices. 6 of 6 slices means I have how many whole pizzas? 1. So a fraction that has the top and the bottom the same, or if I have 1 whole of something, I can just replace that with the number 1. That is what that means. So So if I take a look, and now I've got a pizza with a slice missing. How many are now left? I have 5. How many did I start with? So I now have what fraction of my pizza left? 5/6 of my pizza. So how many slices were taken? Well, 1 is missing. So what fraction of my pizza was taken? 1/6 of my pizza is taken. So that's when you were introduced to fractions way back at the beginning, this is likely how you were introduced to them. They are used to represent a portion of a whole that has either been taken or remains. If 2 people were to share this whole pizza equally, how many slices would each person get? Well, I've got 6 slices that are, this should be equal in the pizza, unless you got some crazy person with the knife there. I'm dividing that by 2 people. So, how many slices does each person get? How'd you do it? Yeah. You divided it. I have 6 slices. I'm dividing that into 2 people. I'm going to have 3 slices. So what fraction of the pizza does each person get? Sorry? Right. Because I'm starting with 6 slices. Each person gets 3. So that represents 1/2 of the pizza. So these are what we call equivalent fractions. They mean the exact same thing. 3/6 and 1/2 are the same. And we're going to look, the first thing we're going to look at today is reducing these things or simplifying these fractions. 3 of 6 has to be 1/2, and we're going to show you, we're going to review how to reduce these things. How many slices would each person take if there were 6 people? 1. So each person would get 1/6 of the total. 1 slice of pizza per person divided by 6 slices. And everyone would leave angry because no one wants 1 piece of pizza. Fractions have 2 parts. What do we call the top part? The numerator. Or if you read that Calvin and Hobbes comic on the front of your course outline, Hobbes calls it the numberator. It's not the numberator, it's the numerator. What's the bottom called? The denominator. The numerator is the number of equal parts taken or left, depending on the context of the question. The denominator is the total number of equal parts in the whole, or how many there were to start. And fractions can be written in 3 types. We can have proper, improper, or mixed. Who remembers what these 3 things are? What is a proper fraction? Or actually any of these. What's a proper, what's an improper, what's a mixed? So someone who remembers any one of these 3. What do you got?
Proper is when the denominator is bigger than the numerator.
A proper is when the denominator is bigger than the numerator. Because if a fraction represents a part of something, you can't have more things taken than there were to start with. So give me an example of a proper fraction then, something with a denominator bigger than the numerator. Someone just shout one out.
1/2.
Sure. 1/2. The denominator is bigger than the numerator. You betcha. So if that's a proper fraction, then the improper is the exact opposite. An improper fraction is one where the numerator is bigger than denominator. Someone give me an example of that.
2 whole.
Yes, so 2 over 1. Someone give me another one. With a denominator that isn't 1. Sure, 20 over 10. 3 over 2. Anywhere where the numerator is bigger than the denominator, these fractions are called improper. And what's a mixed fraction? Sometimes these aren't called mixed fractions. Sometimes these things are called mixed numbers. Yeah. Yeah, it's when you have a whole and a fraction. A whole number and fraction. Hassan, you want to give me an example? 1 and 1/2. You bet. When you're ready, flip the page. So that's what fractions are. What are fractions good for? Let's talk about simplifying fractions or reducing fractions. From this point forward, everything that you do for me that results in your answer being a fraction, you have to have that fraction in simplified or reduced or lowest terms. What does that mean? If I have a whole pizza here, this fraction represents, the fraction that represents a whole pizza is I have 6 of my 6 slices. If somehow I take away half that pizza, what I have left here, we said it before on the other page, was 3 of 6. I have 3 slices of the 6 that started, but that is not the simplest way to express what fraction of a pizza I have left. What is the simplest way to explain how much pizza is left? Yeah, half a pizza. If you're throwing a party, no one's going to say, oh, I got 3/6 of a pizza left. Who wants it? There's a half a pizza. Who wants it? So this is the simplest way to do it. And how do we get from here to here? There's 2 ways to do it. You have 2 methods. It doesn't matter which method you choose. This you've seen before, but we'll take a look at it. The first method, and this is the one that often involves the most amount of work, but we'll get you there every time. The first method is to divide the top and bottom numbers by prime numbers. These are the first chunk of primes. What is there, 8 numbers there, 9 numbers there? These are the first 9 primes. A prime number is special. Why? Do you guys remember what a prime number is? Why do we care about primes? Someone whispered there at the back. Do we know? You don't remember? Was he right? He whispered something. No, he was wrong? Okay, then he shouldn't say it out loud. What's a prime number? And why are they special?
So they only can be divided by what?
And?
Their
And themselves, yeah. So a prime number is only divisible by itself. And 1. And so one of the ways to do this is to divide these things by primes. What is the, so if I take a look at this fraction, I have 6/54ths. The smallest prime number that we can see that can be divided out of 6 and 54 is what? Well, it doesn't have to be the smallest, but what's a prime number that you can say is that divides out of 6 and 54? 2. How do you know? They're even. The 2 is the easiest one to see. If both numbers you have are even, that means they end in a 0, 2, 4, 6, or an 8, then they have to be divisible by 2. Because both of these will satisfy that, let's do it. Let's divide them both by 2. 6 divided by 2 is 3. And 54 divided by 2 is? It is in fact 27. And if you can't do that one in your head, that's cool. That's fine. There's all sorts of ways you can do that. Who said 27? How'd you do it? Did you just know in your heart of hearts? You didn't do any mental arithmetic? You have it written down? Where? Well, how'd you do it the first time? Sorry?
Like,
Oh, you tested the numbers and you started doubling them. So you said, okay, 25 times 2 is 50.
yeah.
So 26 times 2, 6 times 2 is 12. So 26 times 2 is 52. So then you did 27.
Yeah.
7 times 2 is 14. So it's going to end in a 4. So 27 times 2 is 54. Yeah, that works. Sure. As long as there is. So everyone's, you've got all sorts of mental ways to do this. That's a great way to do it. Start doubling things, you betcha. Because this is actually past your chart. If you look at the 2's on your chart, they end at 40. So you can extend your multiplication tables. You can say, oh, that's going to go 42, 44, 46, 48, 50, 52. 50. You can keep it going if you want. But there, or you could long divide. I showed you guys long division. Someone in my other class was like, oh yeah, I'm going to crank this out. 54 divided by 2. Okay, 2 goes into 5 twice. 2 times 2 is 4. Carry the 1. Drop the 4. How many times does 2 go into 14? Oh, it's 7 times. So 7 times 2 is 14. It doesn't matter how you do it, whether you long divide on the side of the page or whether you have a technique in your head. You got to be able to divide by some of these primes. Is this thing as simplified as it can go, or is there another prime I can divide out of these? Both of these numbers are divisible by 3. Say that again? Oh, no, from here. From this new fraction, 3/27. Argue, hopefully easier than that. Yeah, Mercedes? Sorry, John. Yeah. It's going to be 1/9. Because 3 divided by 3 is 1. 27 divided by 3 is 9. And we're done. So when you're dividing by primes, you want to take it as far as it can go. You don't ever have to go back to the beginning. You just have to do the next newest fraction. Or, if you can see it right away, one way to do this is to find a GCF, or the biggest common factor that can be divided out of the top and the bottom. Did anyone notice that there is what the biggest number is that can divide out of 54? 6. Because 6 times what is 54?
9.
6 times 9. So we could just jump straight to 6. If you've got some of the bigger multiplication tables in your head, that's cool. Jump straight to the final answer. 6 divided by 6 is 1. 54 divided by 6 is 9. But if for whatever reason you can't remember quite what 54 is, and there's two that always screw with me. The 56 times, what divides out of 56 and what divides out of 54, I still get those screwed up in my head. 54 is 6 and 9, 56 is 7 and 8, but I will forever get those messed up. Sorry? If we leave it as a fraction, this is done. But if I do the division and turn it into a decimal, you're right, it's going to go on forever. But we're not going to do that yet. The decimals are coming. Okay, so that's simplifying fractions. I'm going to give you 10 minutes. No, maybe not even. I'm going to give you 5 minutes. I want you to crank out this page. On your mark, it said go. If you haven't already, get her done. I know some of you have already done this. 5 minutes. We're moving on. Crank out those fractions. There's 12. And all you have to do is reduce them. You don't have to change them into mixed or decimals, or leave them as they are, but reduce them if you haven't already. They have to be in lowest terms. So those ones out of question 1, write the fraction and then reduce them. Sorry, what question? So you're doing 14 to 54. So reduce the fractions, they're both even. Divide them both by 2. 14 divided by 2 is 7. And 54 divided by 2 you're going to get 27. So you're going to have 7 over 27. Does 7 go into 27? The 7 times tables go 14, 21, 28. Because you can't take that into curve. So 7 over 27 should be the final answer. I don't want you to actually do the division. Yeah. Just reduce the fractions. You're working. Adjust this almost there. Sure, that's in the beginning. That will come up. Okay, I'll get you to note that. We'll just cut. Right now I want you to get rid of the fractions. I'll just get that Okay, let's talk about some of these. Let's see where we're at. Don't make your life harder than it needs to be. Don't do more work than I ask you to do. And don't do so much in your head that you guys make mistakes. I really should wait for Carson to get back because he needs to see one of these. Okay? So for these first questions, I walked around, I saw a lot of you guys doing stuff in your head, and a bunch of you guys that were doing stuff in your head made mistakes. So give yourself permission to show a little bit more work. I had a whole bunch of students who said, I hate showing work, I hate showing work, I hate showing work. Okay, cool. Then you're going to constantly be making the same mistakes. Let's take a look at these first 3. If Gurman baked 12 cookies, Gurman, are you a baker? Okay. Well, let's pretend, Gurman, you baked 12 cookies, and then you ate 4 of them. Because why else would you bake cookies if not to eat them, right? What fraction of the cookies did he eat? Well, he had 12, and he ate 4 of them. So this is the first thing you should write. There were 4 eaten of the 12 that were there, and now this thing can be reduced. I can divide 4 by 4. I can divide 12 by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. So 1/3 is the fraction of cookies, Gurman, that you ate that you baked. Okay? So this is, and then this is the work I want to see. Write out your fraction, then reduce it. Maya has 24 boxes, pencils in a box, 18 pencils have a number 2 on them. 6 of them are number 3. What fraction of the pencils are number 3? Well, there are 6 of them, of the 24 of them, and then reduce. 6/24, 6 divided by 6 is 1. 24 divided by 6 is 4. So this should be 1/4. Walking around, I saw some of you make this mistake. You're getting your 6 into 24 and your 8 into 24 confused. I saw some people, and I know exactly what happened in their head. They're like, okay, well, 6/24, well, 6/24, 6 goes into 24 3 times, so this is 1/3. Nope. It's not 1/3. And if you actually write it out, you're going to be less prone to making those mistakes. Write out your fraction, then reduce. And the last one, in this first chunk, Axton has 15 roses, 6 are yellow, 9 are red. What fraction are red? Well, there are 9 red of 15 total. 9 and 15 are both divisible by 3. 9 divided by 3 is 3. 15 divided by 3 is 5. Show your work. You won't make the mistakes. And then these are the answers to the bottom ones. All I want you to do is leave them in as fractions. There's nothing fancy you have to do. Comments, questions, concerns. Does anyone want me to do any of these 9? I showed a little bit more work for some of them. Stop doing so much work in your head, and you won't make the mistakes that I'm seeing you guys make as I walk around. Take a look. Does anyone want me to do any of these? I do want to take a look at these bottom ones here. I saw some of you guys having issues with these ones. If you can't, some of you wanted to jump straight to, well, 14 divided by 7 is 2, So you went straight there and you said, okay, well, 14 divided by 7 is 2. That's true, but then you stopped and think, well, does 54, can I divide 7 out of 54? Remember, if you guys aren't sure, you have this tool. All of you have the times table, the multiplication table. Feel free to use them. And I showed you how division works with this thing. If you want to know if 54 can be divided by 7, you go to your 7 chart and you go down. Does 54 show up anywhere? No, 49 and 56 are there. 54 is somewhere in between. So no, 54 does not, or is not divided nicely by 7. So you've got to go back and take a look and do this one again. They're both even though, so maybe try dividing them both by 2 to start. 14 divided by 2 is 7. 54 divided by 2 is 27. Now, can I divide 7 out of 27? No, because my 7's times tables go 21 then 28. You have the multiplication table, use the multiplication table. And then something like this, I didn't say that you had to convert it into a mixed number. You can leave it as an improper fraction. Both of these are divisible by 5. 100 divided by 5 is 20. 55 divided by 5 is 11. So that's these 9. Carson, I want you to check these top 3. Compare what you got with what I got. Specifically B. I want you to take a look at B. You did too much in your head. I'm pretty sure it was yours that I saw. You reduced that. You were gone when I said it. It's give yourself permission, all of you, to write down the original fraction and then reduce it. You'll avoid making the arithmetic mistakes that I see so often in your head, or that happen in your head that get down on the paper. Okay, so this is a skill that you guys would have learned at some point back in middle school. It's one that I want you to employ. Always, always, always reduce your fractions. Now, let's look at converting these things. We want to convert between mixed and improper fractions. Where's my mouse? There's my mouse. I'm happy to hear that. That's great. Be so smart. I want this guy here. We're going to look at converting mixed and improper. Okay, so got some fractions. I've got a whole pizza, and we cut it into some slices. Then I cut it into some more slices. If I have one whole pizza, that's the same as having one whole pizza. If I cut the pizza into 2 equal slices, well, I still have one whole pizza. But now I can represent that as having 2 slices of 2 slices. I have all of the slices that were available. And likewise, I can say, well, even if I cut it into 4, I still have one whole pizza, or I have 4/4 of my pizza. No one says that. Everyone just says I have a pizza. But we can use this to represent converting back and forth between fractions. What happens if I have 1.5 pizzas, or a whole and a half a pizza? To represent that, I can write this as a mixed number. I have one whole pizza, and I have half a pizza. Down here, I can use a mixed number to represent this. I have how many pizzas? 2 wholes and 1/2. Or I could take my 2 whole pizzas and I could cut them into the same fraction of pizza that I have over here in my fraction of pizza. How many or how much pizza do I have here now? What's another way I could represent this same amount of pizza? How many halves do I have here now? 5. Is this the same amount of pizza as this? Is 2 whole pizzas and a half a pizza the same as having 5 halves of pizza? Yes. So this is what it looks like to convert back and forth from mixed to improper fractions. And we have a nice, simple way of organizing these steps, but this is what we're doing. We're finding two alternate ways to write the same thing. One is a mixed number, the other is an improper fraction. Flip the page. Here are the steps. You've learned this before, so perhaps you can help me fill this in. If I want to convert a mixed fraction or a mixed number to an improper fraction, what do I have to do? Yes, Hassanjo. Multiply the whole number with the denominator. So I'm going to go on this one, I would go 2 times 2, and then what do? I take that result and I add it to the numerator. So a nice simple way to convert this thing, 2 times 2 is, plus 1 is, so it's going to give me 5 over 2. Because 2 times 2 is equal to 4. 4 plus 1 is 5, and the denominator stays the same. You bet. Yes, you may. So, what's this one going to be? Five times 3 is? So we multiply these two together. We're going to get 15, and then we're going to add it to the numerator. So 3 3/5 is the same as what? 18 over 5. The denominator stays the same. I'm going to give you another example here because I don't think I throw it anywhere else. Something I see students oops all the time is converting mixed fractions that also happen to be negative. What happens if I have this? Let's go -2 and 3/5. How do I convert that? Someone want to be brave and take a guess? There's a mistake I see here all the time. Hassan Joe. That is exactly the mistake that I'm trying to identify. Okay, so Hassan Joe says, let's say maybe, thank you for giving me an example here. Maybe this thing is -7 over 5. Hassan Joe, how'd you do it? You multiplied the 5 and the -2, and you got -10, and then you added 3, so -10 plus 3 is -7 over 5. Maybe it's this. Does anyone think it's something else? Austin Joe, do you think it might be something else? No, you're pretty set on that one? Sorry?
I think it's positive. Same answer, but it's positive.
You think it's the same answer, but it's positive? How would you get the same number but positive?
Because you're multiplying 5 and 2.
So 5 and 2 is 10. And now you're subtracting the 3? That's an interesting thought. Does anyone have any other thoughts? There's a reason I'm throwing this one up here. Yeah, Sean?
-13 over 5.
Maybe it's -13 over 5. Let's talk about this, shall we? If this number weren't negative, let's say it was just 2 3/5, what would the answer be? Well, I would go 5 times 2, which is 10, plus 3, which is 13. So if this number were positive, then my answer would be 13/5. Just tossing a minus sign out front, it's important to remember that this is one number. 2 3/5 is one number. So if I have a minus sign out front, this whole thing needs to end up being negative. If you just say, oh, 5 times -2 is -10, and then you add the 3, you're treating these two as separate numbers. You're saying that, oh, the 2 and the 3/5 aren't part of the same number. And that's how you're going to get -7/5. When you've got a fraction that's negative, you need to set it up like this. you need to look at what the fraction is before that minus sign is there and convert. 5 times 2 is 10, plus 3 is 13, and then you make the thing negative. Making it negative is the last step to the problem. So, can we all see why Sean's correct? Are we cool with this? Austin, Joe, do you see the mistake you made?
I saw it when you were talking.
As soon as I said it? Thank you so much for being willing to be the person that identified exactly the point I was trying to make. So it's not that, it's not this guy. You got to be real careful how you convert these ones. Ignore the negative until the very end and use these steps. 5 times 2 is 10, plus 3 is 13, and it happens to be negative. Okay. I want you to crank out these 9. I'm going to give you a couple minutes to do that. Yeah, German. You finished them all? Yeah, okay, go to the bathroom. We'll check when you come back. Except I want you to change, I want you to make the bottom 3 questions all negative. I want them to be -3, and so any of you who worked ahead, now go back and fix this. I want you to make G, H, and I all negative. And I want you to convert those fractions, but with negative values. See, this is why it's not always smart to work by head. Convert those 9. Many pages ahead. Okay, so compare your answers with mine. Boom, there we go. And they appear. Comments, questions, concerns on anything I did? If you got something different, check it. Don't assume that you're the one that made the mistake. Unless you can see that you made the mistake. Questions about any of these? Carson, I meant to tell you earlier, but I love your shirt. It's a great one. Okay, then the last thing we're going to do today, flip the page. We're going to go the other way. We just went from mixed to improper. Now we're going to go from improper to mixed. Something that you guys have seen before at some point in the past. But now we're just going to review and give you guys some time to practice. This will be the last thing we do today. And then I'm going to give you some homework. So, to go the other way, if I want to convert an improper fraction to a mixed number, I've got a way to explain it here. I'm going to cover that up for a sec. And I'm going to ask you the question. If you're looking at that and I asked you to convert that to a mixed number, does anyone want to explain how you did it? Forget my instructions. How did you do it? Yeah?
So I found 2 by 5, which was 10 closest to it, and I minus 10 from 11, 10 from 11, which equals a 1, so it's 1 to 2.
So why did you multiply the 2 and the 5 together? Let's go back to that piece.
That's the nearest number to the 11.
Because multiplying by 5 gets you to 10, and 10 is the closest number that you can get to 11 without going up 2. Okay. So if I multiply this by 4, that would be 8, but there's another multiple of 2 in between there. Okay? Does anyone have another way to think about this? What you've just said is exactly what my instructions tell you to do. Multiply the denominator by a whole number until you get as close without going over. Does anyone look at this and say, okay, no, I'm going to think about this a different way? Austin, Joe, you almost put your hand up. No, you sure? There's another way to think about it. This is one of 2 ways to explain it. When I'm doing it myself, I don't actually do it this way. I do it a different way. Does anyone think about a question like this any different way?
Dividing the numerator by the denominator.
I think about it as division as well. I look at this thing and say, okay, how many times can I divide 2 out of 11? It gets you to the same spot. Well, the closest multiple of 2 is 10. So we end up in the same spot at the end of the day. I can divide 2 out of here 5 times. So that becomes the whole number that I have here, because I can divide 11 by 2 5 times. So there is not one way, there's not just one way to think about any of these problems. And then if you're looking at it as division, now we're going to say, okay, well, now we're at the same spot. If I can divide it out 5 times, 5 times 2 is 10. And now we get this set of instructions here. I subtract those wholes out of my numerator. So I'll demonstrate what I mean here. So the steps that I've got written down, if you don't think about it any other way, then do it this way. Multiply the denominator by a whole number until you get as close to the numerator without going over. We've already said that number is 5 because 10 is the closest multiple of 2, that I can get without going over 11. The number you multiply to the denominator becomes the whole number you have out front. So, in this case, 5 is the whole number that I have out front. And I want to subtract the numerator from the answer I got when I multiplied. So 2 times 5 is 10. So my numerator now is going to be 11 minus 10. The denominator stays the same. 11 minus 10 is 1. So this thing is going to become 5 and 1 over 2. Often we don't write nearly as much work with this, and you guys don't have to. I'm not asking to see all this work, but I want to make sure that you understand what the steps that you're taking to get to this point. So here we go. If I'm doing 15 thirds, this is actually a nice clean one. Is this thing going to give me a mixed number?
No.
No, someone said no. Why is it not going to give me a mixed number? Because, oh no, this is an improper fraction, but this improper fraction is not going to be mixed. It's going to be, sorry? It's going to be a whole number, because this one divides nicely. This is the same as 5 and 0/3, because 3 goes into 15 cleanly 5 whole times. So there's no reason we don't have to write this fraction in here. Because if you look at what's going on here, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, and 3 times 5 is 15. This goes cleanly, so you'd have 5 and no thirds left over, which is just 5. Let's do the next one. That was nice and easy. 14/5. This one's going to be slightly different. Yes, Carson, I see that hand. Oh, no, you're stretching? Never mind. Okay, so let's take a look here. How many times does 5 go into 14? It goes in twice, because 5 times 2 is 10. 5 times 3 would be 15. Having a handle on your mental arithmetic at this point is going to start to be useful, or you can use your multiplication tables. If I look at my 5s, it goes 10 and then 15, which is going to give me 2 and then 3. So 5 times 2 is 10. So 2 becomes my whole number. And then 14 minus 10 is 4. And the denominator stays the same. So 14/5 becomes 2 and 4/5. That is a great question. This is bad C.
Sure.
No, this isn't bad C. This is bad C. Yes, no, this is not Shobit's class.
Okay.
I'm supposed to have a different peer tutor in this
Okay,
one.
no worries, my bad.
This is Adafa's class.
Okay, thank you.
No worries. Shobit's in C block. Okay, so questions about what I did here? Do you remember this from long ago? Well, we're going to find out real quick. I want you to crank out these 6 questions for me. On your mark, it said go. If you're done, that's great. You'll have 3 minutes to crank these out. We'll check them, and then I will free you to work on some things. So this one should be this. I'm going to write my answers down in here. This one's going to be this. This one's going to be this. Ooh. Need to make sure you write it in lowest terms. C is a tricky one. Make sure they're in lowest terms, guys. Okay, I'm done. Are all of you done already? No, I see some pencils going. Mercedes, you're done. Are you done these 6? Nice. I still see some pencils going. Okay, compare your answers with mine. Questions like C, you need to make sure that your final answer is in lowest terms. 3/6 can be reduced to a half. You need to make sure you do that. Oh, I oopsed on this one. I made a mistake on F that nobody noticed. Well, no one said anything. You were about to before I caught it? Okay, so there you go. Comments, questions, concerns on any of these 6 now that, there's not a mistake written there. And here's what I want you to do. I want you to flip the page. I am not going to assign all of these. I'm going to assign subsets. So, on this first chunk, I'm going to assign aces. Have you guys ever heard of aces? When I say aces, does anyone know what I mean? Okay, when I say aces, what I mean is odd letters, which doesn't make any sense because numbers can't be odd or even. When I say aces, I want you to do A, I want you to do C, I want you to do E, and then I want you to keep doing every other letter. So you're not going to do F, but you're going to do G. You're not going to do H, but you're going to do I. So in the first chunk, I want you to do aces. All it says, simplify the fraction. On this chunk down here, I want you to do BDFs, which is exactly the opposite of aces. It's B, D, F, and then you keep alternating. I want you to convert those mixed fractions to improper fractions and simplify. So you're going to do aces on the first chunk. You're going to do BDFs on the second chunk. I want you to flip the page. I want you to do aces here. So A, C, E, G, I, and H. Wow, this letter got screwed up. It shouldn't go G-H-I, G-H-I. It should go G-H-I, J, K, and L. I don't know how that happened. But I want you to do aces on this page or every other letter. And then, improper to fix, mixed and improper, and this one is, I have a puzzle problem for you here. I want you to tell me what the difference is between a 16-ounce brick and a carpenter. I want you to do that guy. And how this works is you do each exercise, you find your answer in the set of boxes, and then you write the letter of the exercise in the box containing the answer. So, for example, where is it? Now let's do the first one. 9/4. I want to write that improper fraction as either as a mixed number with the fraction lowest terms or as a whole number. So 9/4 is going to be 2 and 1/4. So I find 2 and 1/4, which happens to be right here, and I'm going to throw an S in that box. And that's the only one that has 2 and 1/4. So it's the only place that's going to get that letter S. So I want you to do this page. The next page is optional if you want to do it. Why did the football coach send in a bunch of second string players? If you want to do this guy, this page here will be optional. But you've got your practice. I want you to do aces, BDFs, and then this page here. If you've got comments, questions, concerns, you want to check your answers, let me know. Otherwise, may the force be with y'all. Giver.